All right, this is just a quick reminder or video on Arrhenius acids and bases. So if you watch the other video, you'll remember that our Arrhenius base, or acid rather, an Arrhenius acid is one that dissociates to make H plus in solution. And the classic example we went with was HCl, which breaks into H plus and Cl minus. And so a lot of acids fall into this category where they can make H plus and some other anion. And a lot of times you're going to see an H sort of at the front of the formula is a good idea that this is an acid, but there are plenty of other acids where that's not quite as clear. But usually a big hint is you'll see some sort of H at the front, which represents that it's an acidic hydrogen. Again, that's not 100%. An Arrhenius base is one that dissociates to make OH minus in solution. And again, that would be like NaOH becoming Na plus and OH minus, or MgOH2 becoming Mg2 plus and 2 OH minuses. These are Arrhenius bases. But be careful of this OH at the end. It is not always an indicator of a base. For example, ethanol, C2H5OH, this is definitely not a base despite the OH. This is an alcohol. So the way you can kind of tell the difference is the bases are usually ionic. They're coupled with some sort of metal. So this can easily break, MgOH, NaOH, but this is not going to break in the same way. So just because it has an OH at the end doesn't mean it's a base. But a lot of times, if it's got a metal and an OH, it is an Arrhenius base. Now, these are not the only definitions out there, as we're going to see in this next video coming up. This is a very restrictive definition, so there are plenty of bases that don't fit this definition, that fit another definition which is more broad, that we'll get into on the next video. So again, this is a quick refresher. Until next time, I am Derek Genova. Have a delightful day.